Welcome to Intensified Algebra. This is Mr. Villanueva. Today's lesson will be Topic 3, Lesson 5, and we are on page 97 in your workbook. So I'll give you guys a couple of seconds to find that page. If you need more time, pause the video. Okay, open your books to page 97. Okay, so this is lesson 5, using expressions to represent relationships. Here's the lesson 5 opener. Magic number puzzles use algebraic expressions to show how a starting number is related to an ending number. For example, if the expression for a puzzle is 3n, this tells you that the ending number is 3 times the starting number. You can represent the relationship between the starting number and the ending number with a mathematical rule. For the puzzle with expression 3n, you can write the following rule. So ending number equals 3 times the starting number. Okay, so down here it says, use the rule to complete the following statements. If the starting number is 5, the ending number is, now remember, here's our rule. We're going to go 3 times our starting number, which is 5. Okay, so we're going to place a 5 right into here. 3 times 5 will give us, I'll write that in right here. Our ending number, 3 times 5, would be 15. There we go. Sorry about my poor penmanship. So down here, we're just going to go ahead and write in 15. Okay, and I'm going to go ahead and continue down here. If the starting number is -2, what's the ending number? So we're going to have 3 times the starting number, which is -2. So 3 times -2, that is -6. Our ending number equals -6. All right, if the starting number is 4.5, so we put in 4.5 here. It's going to be 3 times 4.5. Let's see, I'll write that in. Times 4.5. Okay, so 3 times 4.5 is going to give us 13.5. Okay, so go ahead and write that in. Oops. Let me get rid of that. 13. That's even worse. 13.5. Okay, if the starting number is n, the ending number, so here's our starting number. So in place of our starting number, we're going to type in n. So 3 times n. 3 times n is just 3n. Okay, so when the starting number is 5, our ending number, I'm sorry, I'll read number 2. Number 2, organize the information from question 1 into a table. So when our starting number is 5, our ending number is 15. So we're just going to copy these in. Okay, when the starting number was -2, we ended up with -6. And when our starting number was 4.5, our ending number was 13.5. Okay, and then when our starting number was n, we end up with 3n. Okay, so that's number 1, number 2. Let's go ahead and go scroll down to number 1. And number 1, I'm going to show you guys some animations that go along with this. So the next part of our lesson is the core activity. It says you have been using patterns to solve problems. One important pattern in mathematics involves a relationship between numbers that you substitute into a rule called input values. And the answers that the rule gives you are called output values. You will now explore these input-output relationships. Okay, the rule below represents the relationships between the starting number and the ending number for a different magic number puzzle. You can also use the rule to figure out the ending number that goes with each of the starting numbers in the table. So here they give us a rule. Our ending number is going to be equal 3 times the starting number plus 1. So here's our starting number, the input. We're going to first start off with this -2. In a magic number puzzle, think of the starting number as the input and the ending number as the output. Okay, so the input is what we're putting in. We're going to place it right in here to the input. Our result from this expression here will give us our output. Okay, so the way I look at this is, okay, here are our inputs, and we're going to place them here. So we put in a number, okay, and this machine here is going to do something to it. This is the process, okay. The machine is going to perform a process, and then it's going to put a number out, and that is our output. Okay, so we're putting in our -2, putting it in place of our input. It's performing the process, and out comes an output. Okay, so let's go ahead and let's think about this for a second. Try to think before the machine does it for you. If we put in, here's our input. If we input a 4, it's going to perform this process here. So we're going to have 3 times our input, which is 4. So 3 times 4, that is 12, plus 1. What will our output be? And we're going to let our machine do its thing. So here we have the 3 times 4 plus 1. And that will give us 13. Okay, and we'll watch them put the rest of these inputs in. 3 times 10 plus 1. That gives us 31.